Welcome to episode 5 of our series, Wi-Fi Scanner series. So we are back again with the same setup as we have left in episode 4. So if you can see, this is the battery charging module. This is it is now disconnected, and we have ESP32 connected to the TFT display. So from here we will take forward, and now in this episode we are going to see how to use the touch panel. So as you are aware that, and we have seen earlier, so it was a one-way communication, right? We are able to just use the TFT and see the like Wi-Fi and BLE scan results on the screen. But now in this episode, what we are going to do is that we are going to add touch, and so that we can interface and control the scanner. So we'll build this in different parts. As a first part, we are going to just set up our framework, touch framework, whether the touch is working fine correctly or not. So that we'll see. And this next after that we'll integrate with our original episode 4 code. The hardware requirement remains same. There is no additional hardware requirement because this TFT has a built-in touch options, and we'll see quickly the touch pins that are available for connecting. So if you just let me show you the touch pins. I hope you can see. Let me just zoom in. So if you see the last 5 pins, T underscore IRQ, that, and T underscore DO, T underscore DIN, T underscore CS, and T underscore CLK. So all these are touch pins. That's it is marked by T, starting with T. So we'll be using this touch pins and connect this. Right now I have already connected, but we'll show you how to connect and which all pins will connecting to ESP32 and on the screen in some time. So this is how these additional pins will be using. So this TFT display has a inbuilt, like we have a separate touch controller and with a separate SPI bus, and separate than the display SPI. So you can use both, you can share the SPI bus, but for this project, to make it simple, we are using separate, as this display provides the separate SPI bus for touch. So let's move into the screen and see the pin connections that I have done mapped with the ESP32. So in this episode, as I mentioned earlier, we are going to see the touch navigation and some improved UI. So our main target will be, like this part we have already covered, SPI interface and TFT display. Like, so we next in today's episode we are going to use the SPI touch using the touch controller and the touch panel. So our target for today is this, and along with that improve the UI. So this is going to be the main content of for this episode, and I have shown you the wiring of the touch pins and where the touch pin is located. So now we'll see how we are connecting it to the ESP32. We are connecting like DO and DIN pin to pin GPIO 16 and 17, clock pin to 32, CS to 25 and 26. Here, just as a reminder, you can share the pins, clock and CS pin you can share with your earlier SPI display pins, but for this project we are not going to share the pins, and we are using separate SPI bus. But if you remember our earlier code, the display part, where we have used clock as GPIO 18 and MISO and MOSI as GPIO 19 and 23, and GPIO 5 as the CS pin, and DC pin as GPIO 27. So this is our hardware part. So there is, as I mentioned earlier in my previous episode also, in this episode we are not going to introduce any new hardware. So we are going to use the same ESP32 dev board and the TFT display, which has a support for touch pins. So all our code for today will hover around this touch pins and the SPI display for touch. So you need necessary libraries. So we'll shortly show you that. So after you launched Arduino IDE, just go to the libraries, manage libraries, and search for this particular library. We are going to use this file. So since I have already installed, so it is showing me installed. So make sure you have this installed. This is XPT2046 underscore touchscreen by Paul. So you install this one, and this is the one that we will be using it. Once you are done installing, let's move into a sample code which will be using to test the touch options, whether the touch is working correctly or not. So that now we have seen the pin connections with the ESP32 and the touch pins along with the ESP32 pins. So next thing is the touch, testing our touch, whether it's working and whether the pin connections are fine or not. So in this particular, this is a first calibration test program where we are just trying to see whether we are able to capture the coordinates from the touch screen. So what we'll do, we'll just touch, call the touch, and when we touch, we'll get we'll try to get the coordinates that it is capturing it and display. So this is just the basic thing, whether we are data transfer through the touch SPI is successful or not. So this will establish our pin connections and other things are all good. So before running this, another thing here is that, as you have seen earlier, I mentioned to include this library. So install this library. So we need to include this .h file, and then define the pin connections. So we are using 32 for clock, MISO as 16, MOSI as 17, CS as 25, and IRQ as pin GPIO pin 26. So if you are changing any of your pins, then you need to change that over here also. Next thing is initializing the touch part. So that is we are using this class. So we are passing this pin number CS and IRQ. Next we are this is nothing but the display part. So this method we are calling from our below loop. So here in the setup, if you see the serial monitor, we are connecting to the serial monitor with this baud rate, and then this calling this method, begin method, with the pin numbers that we are using. Next here is we are calling this. So this will, if there is an error, it will show me the error. This is the SPI touch SPI pin, and this is passing the touch SPI pin to the display. Next is in the loop part, where we are actually calling the method. So this loop will infinitely run, and since we are already calling and displaying this method, read method, so here we are displaying it every time. So this will, if you see this, the four corners that we are trying to capture, so it will display on the screen, will tap, and accordingly it will show the coordinates. So this is how this will work, and it will, once we call this read corner, so which we are mentioned over here, so it will display, it will try to capture the pin coordinates what we have tapped, and then it will display on the serial monitor. So this is a very basic thing, and where we are trying to capture the coordinates from the four corners. And this is just you can use instead of four corners, you can use, just if you want to just test whether the data transfer from the touch pins are correct or not, you can use just one call also, that is sufficient, because in our next program we are going to capture the more number of coordinates, so that our framework and our all the coordinates are correctly built. So before further delay, let's upload this code and see the output. So I will pause for some time till the time it uploads, and we'll come back again. So the code upload is complete, and let's move into the serial monitor and see the output. So if you see, I have just restarted my ESP32. So if you see the calibration starting and then touch, here it says touch the top left. So this is what I am calling from here. So this passing the top left, so it is displaying that part, println the name. So touch top left, so we'll touch the top left corner. So I just touched twice, so it's showing left and right both captured. It is incorrect, but yeah. So if next I will touch the bottom and the other four. So all the four I have touched, so it's captured the coordinates. So here it is not important whether the coordinate is correct or not. Here the important point is whether we are getting the coordinates from the touch screen. So if we are getting the coordinates, we are not having 0 or anything different, which means that our coordinates, our touch screen is able to transfer the data from using the touch SPI bus to the ESP32, and we are able to display it on the serial monitor. So this first program will clear that point, and if there is any issue in your wiring, you will get here you will not get this result. You will get something 0 or some random numbers, too high number like this. You may get a constant number for all if there is any issue with your MISO or MOSI pins, so which I was getting earlier. So my pin connection was not correct, like the wire was not correct, that jumper wire. So I was always getting a constant value for Z, and X and Y, it was always 0. So if you encounter that, which means that there is a pin connection issue, you need to check the wirings. Next we'll see the next code, and where we are little enhancing our test calibration code, and there what we'll do, we'll capture the 9 coordinates from all the 4 corners and also the middle line. So we'll capture 9 coordinates, and that will the way we'll capture is that we'll display a cross on the screen where we need to tap, and that will return the coordinates. So let's see that program and then upload that code also. So this is the next code where we are changing or adding our additional things in our calibration code. So here what we are doing, we are trying to capture the 9 coordinates from the top, all the 4 coordinates and the middle row also. So for this we are adding additional file tft_espi.h, because we will be using our touch display, where we will display a cross and where we'll do a tap. So rest are same. Additional one more additional is we are defining the screen width, because we will try to display the coordinate based on this width also. So here this draw target will draw a cross line. So we'll pass the coordinate and then we'll display a cross where we'll tap and we'll capture the coordinate back. So the rest are same. So there is no change in this setup code. The key change is over here. We are like calling that touch the target and that point, and where we'll tap, and that will return the value. So once the value is this will draw the target, and then when we tap, it will return the results, and that x1 target coordinates will display. So here is what we are capturing. After tap, we are capturing the return coordinate, and will display the raw x and y value, and x, y and z value. So before further delay, let's upload this code. For this, we'll switch the camera and show you on the display also, TFT display also, how it looks like, how we are capturing the coordinates. So I'll pause the video once while it uploads, and then we'll come back again. So the upload process, compiling is done, upload process is also completed, and we'll just move down here, and let me restart once, because sometimes it creates problems. I will restart my ESP32. So here if you see, this width is displayed. This is what we are displaying also, and then 3x3 touch calibration. So that's what I mentioned. We'll try to capture the 9 coordinates from the touch screen. So first point is target x20 y20. This is a top corner. So I will show you how it looks in the touch screen. I will switch the camera and show the touch points on the screen, and then once I touch all the 9 points, I will come back into this monitor screen and then show you the how the coordinates look like. So now that I've uploaded, and if you see, I hope you can see the cross here. So touch target 1. So we'll touch over here, and the coordinate is displaying on the screen serial monitor. So we'll switch the serial to serial monitor once I touch all the 9 points and then come back. So we'll touch all the 9 points, second point, then third point, fourth, fifth, sixth, then the seventh point, eighth, and the last one. So now all the touch targets I have touched, and the respective coordinates is displayed in the serial monitor. So I will switch the camera and show you back how it looks, what coordinates it captured, and then we'll, based on that, we'll frame or design our next version of the code where we'll display the buttons. So now if you let me show you in the display serial monitor how the touch look like. So we have seen this, it was showing till 0.1 target X20Y20. So this point was showing on the touch screen as the first target. So after touch, it captured this XY coordinate, raw XY coordinate, and this displayed over here. Second point, similarly, third, fourth, 5th, 6th, 7th, 8th, 9th. So all the coordinates we are able to get. Now based on this, we will frame our next version. So this also denotes that our touch screen will get the XY coordinate for the respective points. So when we design our next version where we show the buttons, we will make sure that the coordinates doesn't move outside this. So our coordinates are within, our button coordinates are within this, so that it is easy to implement the code. You can see, if you are using the same display which I am using, you can skip this test. You can just use the first test and make sure that touch wiring is correct, and you can directly move to the button code where I am displaying the navigation buttons and the display buttons with the correct size and all. So that you can use. But if your display is something some other display, I will suggest you run this code also, so that you get your actual calibration for your display that you are using. The next part of this UI and scanner, the touch screen setup is displaying the buttons. So next what we'll target is display buttons on the screen with some color code, and try to make sure that that is working fine, and then that will be our third program. So next two program, in the fourth there will be another program where we'll enhance that display and use and configure the navigation based on our project requirement. So the way we have Wi-Fi scanner, we have BLE scanner, and we are going to add any additional features that will include in that navigation. So that will be our fourth program. So next two programs, our more focus will be on how closely we can connect to our episode 4 code. So now we have seen the target positions. If you see this, this is what we displayed in the touch screen, and we tapped at all these 9 positions and captured the coordinates. So till now what we were able to achieve is we were able to complete our wiring. That is, we connected the touch SPI pins with ESP32 pins as I shown earlier. So these pins, and tested with the first test program, the calibration test program, which shows where we were able to display the touch coordinates on the serial monitor. So that will confirm whether this wiring is correct, and if there is any issue in wiring, you will get the issue over there only. Next, second program was to check the target positions and get the coordinates, so that we can use that in our next program where we will be designing the button positions. So for that we use the 9 pins, 3x3 matrix, and displayed cross on all these 9 positions and captured the raw XY coordinate. So we were able to successfully capture that XY coordinate, and based on that we'll design our next program where we will be using to display the buttons. So far from what we have covered is that we were able to use our touch controller using this SPI pins, and we were able to detect a touch. We were able to map the raw XY coordinates and calibrate based on the 320 by 240 TFT. So next target is the button. So what we'll do, we'll try to display a header on top, and then we'll have this 4 button Wi-Fi. It will be a big buttons so that it is easy to tap, and we'll have one Wi-Fi button, one BLE button, one scan button, one battery. So this 2 functionality we'll discuss later, and if we are able to implement in this same episode, we'll show you. We'll see if the episode is not too long. If it becomes too long, we'll skip this 2 part for future. But at least these 2 buttons will make it workable. And so once you tap the Wi-Fi, it will show the Wi-Fi scan result, and that will have a home button which will move back to this screen. Again, when we tap the BLE, it will show the BLE scan result, and that will also have a home button which if we tap, it will come back to this screen. So this is how this button framework will work. And once we are able to achieve the first in the first like code, or the third one from the series in this episode, we'll try to display this button with the correct color contrast and color in whatever we want, and make sure that color settings are correct and the layout is correct. Once we are able to achieve in our follow-up program, what we'll do, we'll make it navigation, make sure that the navigation also works. So the next 2 programs will dedicate on this layout and the navigation. So before further delay, let's move into the code. So this is the sample code where we are displaying the buttons. So the key things is this, all the top header part remains same till here, there is no change. This calibration is based on the calibration result that we have found, and if you need more details on how we came up with this value, just comment it in the comments on video, and I will try to answer it as soon as possible. But for this video, I will not go in detail on how we got this coordinate. Next is the touch button layout. So we'll have this 4 buttons as shown earlier on. So first will be the Wi-Fi. So this is the based on the coordinates that we want to display. So you can map this coordinate physically on the paper and then come back here and then use that. But if you are using the same display, as I mentioned, same configuration or the same size of display, you can use this code as it is. So this will display this 4 button, and draw button will draw. So here we are passing like if the different color codes. So TFT black, the fill color, so button color will be black, text color is white. Again, there are few other colors change, like menu, the background we are setting is as white, text color is black, and the TFT is white. Next is the header. So this is the header, and we are displaying at the center. So we are dividing the screen width by 2, and then we are drawing all the 4 buttons one by one. We'll see this running shortly, and then come back and modify this code so that to make it make the navigation work. So let me compile and upload this code, and by the time it uploads, I will pause the video for some time. So now it is compilation is done and it's uploading the code. So for this I will switch the camera once the upload is complete and show you on the screen how it looks like. So now the upload is complete, so we'll switch the camera and show the display UI how it looks like. Since once we upload the code, if you can see the button screen, so as I shown earlier on the screen earlier in our plan. So yes, the header is there, ESP32 scanner, then Wi-Fi, BLE, scan and battery. So nothing will happen right now. So once we tap, it will just change the color, and rest there is no change. So here while you are coding this, you can set your color and choice based on your requirement. So you may want maybe a white background or maybe some other colorful buttons you can use. I have just used the plain two color buttons, gray, black and white. That's it. So based on that, I will modify my next code, where what we'll do is on tap of Wi-Fi will show the Wi-Fi screen without any actual scanner working. Will just dummy screens. So BLE, it will show the BLE screen, but again that will be a dummy screen which will not be a working screen, but just to make sure that navigations work. So once we are able to complete that part, our framework setup will be complete for the touch, and next part will be display integrating with our episode 4 code. And once we integrate with the episode 4 code, then third part will be making change for battery and scan. So these two I will see if I am able to cover in the same video, or whether we want to move to the next video, because if it becomes too long, I will not show the battery and these two button below in the same video. I will try to move it to the next video. So now that we are complete with this third program and we are able to display a button, so we'll move to the screen again and see the next version of this program, where we update the navigation. Again, as I mentioned earlier, navigation with the dummy screens, not the actual episode 4 code. So just making sure that you can use part by part also. If you have not built my episode 1 to 4 code, have not followed and not built, if you're just watching this version of this video, you can just get the pin number from my previous video for display connection and connect it, and you can just use this display framework and the touch screen options to configure in your project. So this, you can build this project in isolation also, but for the display connection in this video, I'm not showing the pin connection, how I have connected to the ESP32 and the display driver. So that for that you can watch my episode 2, where I have shown the display framework setup connecting to the TFT display. Episode 2 or 3, you can watch those 2 episodes. So that will give you clear picture on how I have connected the display, TFT display, and you can skip 4 and come back and use the touch options. So it is up to you whether you want to follow all the 4 series and then come to the episode 5 in this particular video. That is also workable, or you can just, if you're watching starting to watch from this episode, you can move to the episode 3, where I have connected the the display part. So that will help you build this project easily. So before further delay, let's move into the code part of the next version of this navigation screen, and then we'll come back again here to see how the navigation looks like when it's working or not. Now based on this code, now the next version of the code will be to build the navigation. So let's move into that code. So this is the navigation. This is a navigation code where we are navigating the button with the dummy screens. So the main we are using use the same version which we have shown in the previous code, where we are displaying the buttons. So we use the same part, and just that we are enhancing, and on the tap of button we are showing a dummy screen. So we have this declared enum for different screens, like for home screen, Wi-Fi, BLE, scan, battery and so on. And when we press, the rest of the display button screen code is same as from the previous code. On top of that, we are adding the screen, like when we touch home, what will display, when we touch Wi-Fi, what will display. So this is the home screen. So we have defined that home screen where we display the 4 buttons, and that is our home screen. So this is the drawing of the home screen. Next is the Wi-Fi screen. So this the header part, but this is from the previous code. This is the drawing the Wi-Fi screen. So when we tap that, it will draw this Wi-Fi screen. Again, this is a dummy screen, so it will display some data, table and some dummy data, but we'll replace this when we integrate with our episode 4 code. We'll replace it with our actual scanner screen. Similarly, we have a BLE screen. So this method will draw the BLE screen, and when we integrate with our episode 4, we'll replace this code with our actual BLE scan result. This is the dummy scanner result that we will be showing it. So all this different for different screens, we created different methods with the dummy layout. So the draw current screen will draw the actual screens based on the tap. So we'll pass the current screen name, and based on that, whether it's a home screen, whether it's a Wi-Fi screen, or whether it's a BLE screen, it will call the respective methods to draw that layout. So this is how our code will look like. And similarly for where we handle the touch, will like depending on screen home, there are different buttons that will display, and based on that we'll call the respective update the respective current screen variable. And so if it is screen home, and from that screen home, if we tap particular this coordinate, it will change to the screen Wi-Fi. If we tap at this locations, it will change to BLE screen, will current screen will become BLE. If we from that screen, if we tap on this coordinate, the current screen will become the scan, and so on. Similarly for the Wi-Fi page, where we have a screen Wi-Fi, so if we tap at this location, it will, in the Wi-Fi screen, there will be home button, it will move to that variable will be home button, and then based on this current screen value, screen home, it will call that respective method to draw the home screen. Similarly for BLE, so all the screen, Wi-Fi screen, BLE screen, scan screen, and the battery screen will have one additional button, will have a button, home button, which will help to move to the home screen, so that we are not stuck on the specific screen. So for all that, we will have this coordinate which will define we will display the button in this coordinate, and once the tap result is based on this, the current screen value will change to the screen home, and based on this screen home, it will draw the current screen. So now this draw current screen will be, because we have this value, so it will draw the current screen. So setup is not different, it's almost similar to the previous one, though the loop will change here. So based on that, we'll get the touch points, and based on the touch points, we'll call the respective methods. So our starting screen mainly will be the handle touch, and from there we'll calling all the respective methods. So before further delay, we'll just compile this code and upload. And one more point, so if you have any issue in understanding this code or any clarification required in any particular part of the code, you can just mention it in the comment section. We'll try to answer as soon as possible. But so let me upload this code. I think the device was not connected. Yeah, now I have connected. So we'll pause the video for some time till the time it compiles and upload, and then we'll come back again. So the compile part is complete, and now it's uploading the code, and once it's done, we'll switch to the serial monitor. Will just display which screen it is there, and it will show, so that we can test whether the tap is working correctly and it is redirecting to the correct screen or not. So this is debug information which will help you test your program whether it's working as expected or not. So this is compile and upload is complete. So we'll switch the camera and show you the how the navigation looks like, and then again come back here and show you the output of the navigation. Like it will tap it whenever we tap the particular screen, that coordinate and which screen it is, it will show in this as a debug information. So before further delay, let's switch to the other camera and see the output on the TFT display. So now if you see the buttons, it looks same as we have seen in my previous program, because we use the same code, but the difference is the navigation. If we tap Wi-Fi, if you see the Wi-Fi scanner screen is showing. Now again, this UI is a dummy. We'll integrate with our episode 4 so that it displays the actual scan result. Right now it's a dummy screen with dummy data. When we tap back the home, it will go back, take me back to the home screen. If we tap BLE, it will take me to the BLE scanner page. Then we'll home. looks like some issue here. It's no, sorry, it was not tapping correctly. Now if I battery, it will show me the battery information. So again, this is a dummy data, and the battery part I will try to see if I can cover it in the same video, or otherwise we'll move into the next video. The scan result, here we are having both the scan option. So this is again enhancement to the UI, but we'll again see whether we can implement this or not. But at least I think this we can integrate, but because for this we don't need any additional changes, just a integration. Battery may require some additional wiring, so we'll try to see if we can cover quickly in this video, or otherwise we'll move it to the next video. So this is how it will look like. Now the output looks fine. Now color is also same as I have used in my previous version of this code. So it is up to you. If you want to change the color code, you can test it out and then change it accordingly. But this looks little sober color. If you want to use the red color or green color, maybe for different buttons you use different color, so it's easy to visually recognize. That may be also possible. So it's up to you. But this is the how it will look like when we finally integrate. Once we finally integrate, the changes that will come is this screen. So here we'll see this actual scanner result. So now that we are done with our display framework and the touch framework is complete along with the displaying the buttons. The next part of this code, next part will be integrating with this with the actual scan result. Next part of our video, here we will see how we integrate the scan, like all the Wi-Fi scan and the BLE scan, which we have developed in episode 4 with the new framework, touch framework and the touch navigations that we have seen so far. So before heading into the new code, so I'll just briefly show you what we had done in the episode 4 code. So far, like if I have opened the earlier version, the episode 4 file, and if you see the loop method, so here we are calling scan networks once, and then again the BLE scan, and then with a delay. So this alternatively runs like once the scan Wi-Fi scan and then the BLE scan. But in our new setup, we will have the 4 touch buttons on the screen as I have shown earlier in the framework, and each will once we tap that button will move into that screen and then come back again from that into the home screen. So our core method loop will change, and along with that, to sustain, like to maintain that touch framework, we'll add few additional files also. So before I will not go into much detail in this file. If you want more info how this without touch runs, you can watch my earlier video on this for the episode 4. So in this current in the episode 5, that the changes that we have done is, the first thing is that we added this touch file. If you see these 2 files that I have added, so this is a new file based on the touch framework that we have designed so far and calibrated and tested our touch display. So based on that, these 2 files is added. So in this CPP file, we are enhancing that and adding the pin numbers that we have used as mentioned earlier in the video. 32 is for clock, MISO and MOSI is 1617, and CS and IRQ 2526. So this, so if you are using some other pins, you need to define accordingly. Then this touch begin method and the touch, the whether with these methods, and also the get touch, which will give the touch coordinates when so all this defined in this. So this we have in, if you notice the navigation file that we finished earlier in this video, this all were in the single file. So now we have separated into the .h and .cpp file so that it's easy to maintain. So all those methods I have included in this, like getting the point, getting the touch y coordinate and the actual x coordinate. So all this we have included in this, and in the touch manager.cpp. So any changes that we need to do with respect to the touch, we need to just touch these two files. So this is one changes. I will add this file in the GitHub repository for you to easily access and use it. The next change that we have done is in the theme.h. So in the theme, based on the touch UI, we added few additional constants like the touch menu background, menu text, button, and what is the color when the button is pressed, and the color button border. So these additional things I have added for the touch UI. So this changes need to do in your theme.h. And in the display manager, there are a lot of changes, because we will be not drawing the dashboard, but in our current set in the episode 5, the changes that we have done is the main changes that we have done is this draw home, Wi-Fi navigation and BLE navigation, and is home button touched, this method, and the draw message. Draw message I will explain in later in between. And then the battery and the battery navigation, which we are not in this episode, we are not detailing it out. We'll just have a dummy screen. But the key thing here is this 3 and these 4 methods that we have defined over here. So this will be using let me go to let's first so before going into detail of this the new methods that I have discussed, let's move into the config. So here there is two additional like one section that I've added is related to the button position. So this we have added home button position in the config, because we will be using in multiple screens. So we have defined it at one place. And in the INO file, we are going, the major change is in the INO file also. The first change that we have done is included the file, the touch manager.h, because we are using this, and we are not included that touch related file is part of this here, the touch screen XPT2046 underscore touch screen we have included here. It is not required again to include in the INO file. The next thing is initializing, creating an object of touch manager class, and then these two I will discuss in some time when I come to that part of the code. Another important thing that I have added in this file is this different enum value for screens. So we have defined 4 screens. So this also in our navigation code we have included that, and so that part also is over here. And then this initializing the initial screen to the home screen. So this is the initial part of the code. Rest is same as in the previous one, like void scan network, and this all are same. The next part will be the setup. So here the changes that we have done is initializing the touch area. So if you notice that I have commented out the old dashboard code, this was used in episode 4, and in this we have included the draw home. So this will draw the home screen that with the 4 buttons, and before this there is begin for touch initialization. So this method we are calling, so along with the TFT initialization we added this. So basically these 2 changes you need to do for your touch. Next is in the loop. So this if millis will discuss later. So the key thing to understand over here is this part first. The scan interval we'll discuss later, and we'll explain that in some time. Next part of the code is that this particular, if it is touched, so what will happen. So this code, the switch statement, that is it will take the parameter of the current screen. Now initially when we started with the current home screen as home screen, so it will have that value. So our control will be in this case screen home. Now what happens, like when we draw home, it will draw that 4 buttons that we have seen earlier. So we'll see the UI shortly. Right now, we will discuss more on the code, and then we'll switch the camera and show you the actual UI that it looks like. So this draw home will draw the 4 buttons with the Wi-Fi scan, BLE scan, and the battery. So that part is covered over here in this method. So that is defined in this draw home, which is in the display manager.cpp file. So this will draw the home screen. So draw home is nothing but it draws the home screen, and home screen in our case we have defined home screen with the 4 buttons. So this is the same code that I have picked up from the my framework code that we have discussed earlier. So next part in this is this touch. When we are in this home, so it will capture the coordinate if we touch this area, if x is greater than this and this. So what will happen, it will call the Wi-Fi scan. So basically this coordinate define the button coordinate, so the button location that we have given, and if we touch that area, so it will call the Wi-Fi scan. And why we are passing in the scan networks, we have introduced one additional parameter, scan networks true. We'll discuss this also when we discuss the millis that we have skipped right now. So this milli interval, scan interval, when we discuss scan interval, at that time we'll explain why we are passing true over here. So at this moment you need to understand the scan network. So this scan network is called, if we touch the Wi-Fi button, it will call this scan network and store the detail and use it in this Wi-Fi navigation. So this draw Wi-Fi navigation will draw the Wi-Fi page. It will move to the Wi-Fi scan result page and draw that. So this we have also covered, like we have separated this in the display manager, but in our previous code we have covered that part also. So this method, the draw Wi-Fi navigation, I will just show you here. So this is what it is. So it will draw the scan output and draw the navigation, like it will draw the button, the home button at the bottom of the screen, because that will help us to return back to our home screen. So this will draw that button and then display this text in the button, and this is the location where we are drawing it. So this will draw that button, and this scan network is nothing but our old code that we had earlier defined. So this will scan the Wi-Fi networks and display. So we'll go quickly to this method also, because there is few changes that was done here also. Yeah, so scan network. So here we are doing made some changes from our episode 4. So what we are doing, instead of deleting like we had earlier this scan delete on the top, we have changed the sequence. So first we are clearing that network area, that page, the dashboard page, and then drawing the Wi-Fi header, and then the column header and the footer. So all we are drawing with the empty screen. Still at this moment we are still not called the actual scan result. We have not drawn the actual scan result. We are just clearing the existing data and drawing our header and column header, column header and footer, and then we are calling draw Wi-Fi, calling the Wi-Fi navigation again over here. So this will, and then the Wi-Fi scan network over here. So this Wi-Fi navigation, what it will do, it will draw the button, and the button that we have already seen that at the bottom, it will draw the button at the footer. So we'll see the UI and it will be clear at that time. And then let's skip this part, we'll explain at the end. So next is the actual Wi-Fi scanning, where we scan and then display, store the number of networks it results, and then the rest of the code which is from the episode 4. So this all will display in the tabular format, the result. The changes that we have done is over here. So we have changed the way we are drawing the screen because of some issue earlier sequence. Since in earlier we are alternating through Wi-Fi scan and the BLE scan, that issue was not there. But now since we are based on the touch screen, we are moving to this screen. So we are just first displaying the empty dashboard where we are having the scan, nothing in the page, only the headers and footer, and then scan and then display the actual scan result. So this part is because of that. So in between, when we draw this header footer, there is a empty screen shows up. So when we first time come, we'll display this message that's scanning. Next time when the second call it is there, when it is auto refreshing, at that time we don't use this, we will not be displaying. So that is why you see so scanning. So if we pass through, when we pass through, it will display this message, and will pass through only when we are coming from the home screen to this dashboard. Once we are in that Wi-Fi scan result page, the page will auto refresh, but at that time will not show this message. It will auto refresh every 10 seconds or whatever interval we have set. So this is how this BLE, the network scan network works. So initial part changes only on the top, initial part, but the rest of the scanning and everything is same as in our episode 4. And similar change is there in the BLE. So BLE part also, the initial drawing, how we draw the header footer is changed, and same showing this message scanning. It will only show the scanning message first time when we come from the home screen. Once we are on that result screen, this message will not show. It will auto refresh every 10 seconds or whatever interval we have set. The rest of the below code in this part also is same. So this is how the scan network will work from that home screen. Now let's go back to the our earlier method in the loop. So here we are calling, when we are in the home screen, we are calling based on that which area we have tapped, we are calling the respective methods, like whether it's scan BLE or whether it's a scan network, or if it is a battery. So battery part, we are just calling it, but it is a dummy right now. And there is one more scan dummy, there is one more button we had, the third button. So this is also a dummy. So this will also, we will try to incorporate in our future videos. So battery also, it is right now we have designed the page how it will look like, but the value that it is displayed is a dummy right now. So this is how this first case statement is for the home screen. The next case statement is once we are in the Wi-Fi screen. So once we are in the Wi-Fi screen, there is only one possibility of moving to the home screen. So we have defined a button in the bottom, as we have seen in the top footer. This draw navigation will draw a button on the footer, which we'll see shortly when we show you the actual UI. So that button, once tapped, it will move to the home screen. So once we tap that button, so which means that we are in the screen, Wi-Fi screen. So once we tap that, it will set the current screen to home screen and call the draw home. Now draw home will again draw the home page. So this is how it will happen for all the other pages, like once we are in the Wi-Fi screen, or once we are in the BLE screen, or once we are in the battery screen. So this, all the third three screen we have defined. The fourth one we have not yet defined. So that will again, as I mentioned, we'll cover in the later part. So this is how this loop will work, and it will continuously show this. So whatever button we tap, that page it will move, and from that page we'll move back to the home screen. So all this movement and navigation is covered in this loop method. Now this first part we have skipped, the one which we have skipped earlier. So this is what it will do, is the auto refresh part. So once we are in the Wi-Fi screen, or once we are in the BLE screen, the code needs to refresh, like the scan network need to call every time, so that we get the updated results. So that we are calling here. So we are calling with a false parameter, because as you have seen, we don't want to display that message that we are displaying only when we are calling with the first time, when we move from the home screen to that screen. So this scan network false is, that's why we are calling it with the false parameter. And this millis, the last scan time, will define the why we are using this is, this will check the scan interval, and if the scan interval, the last scan time is greater than the scan interval, then it will come into the this auto refresh part. Otherwise this auto refresh will not run. So if we have set the scan interval as 10 seconds, so it will check whether our last scan time is the millis minus the last scan time is greater than 10 seconds. If it is, then it will come into this page, this if condition, and depending on whether it's a BLE screen or Wi-Fi screen, it will call the scan method of that respective functionality. So this is how this auto refresh will work, and that is the reason we are using this milli minus last scan time. And the last scan time we are storing here. Once we call the scan network, and we are storing that time, and in this millis, from this millis we are calling storing in this last scan time, and now we are calling the difference. Based on the difference, it will refresh again. So this is how this works. Similarly, over here also we are capturing the last scan time. Once we scan the result, even if we are coming, when we are coming for the first time, it will scan, show the result, and store that time at which we have scanned in this method, in this variable. And this value we are using it at the auto refresh. So both place, we are, whenever we are scanning, we are storing the last scan time, and then we are checking that whether the last scan was 10 second, whether 10 seconds has elapsed from our last scan or not, and based on that we'll call the respective scan methods. So this will cover the auto refresh. So that is the reason you see this parameter, this millis that we have used over here. And for this we have defined additional global variable, last scan time, and this scanned interval. So we are using a separate constant over here. We are not using the one which we have defined in the config.h. In the config.h we have defined the Wi-Fi scan interval, but we are not using this one. We are using this new constant variable that we have defined globally over here. So this will do a auto refresh every time. So this is how this code works, and let's move into the actual demo of this code, and we'll see how it looks like, and then we'll come back again and explaining few additional area of this code. So now if you can see, I have uploaded that code that we just now saw. So this is the same dashboard that I had discussed some time back while discussing the framework file, the navigation framework. So we have used the same UI. So home screen is this, so which we discussed whenever I was talking about the home screen. This is the home screen. So once you tap the Wi-Fi, it will come here, and if you see this scanning message, this is showing for the first time that now we are in the network Wi-Fi scanner, the Wi-Fi results. So this is showing same number of record. Now after every 10 seconds it will refresh and show. So this 10 second here, when we are refreshing, when we are in this screen, we are not showing that scanning message. That's what we discussed earlier also. So in this screen we are not calling that scanning text, and we are just auto refreshing every 10 seconds, and that 10 seconds is configurable. We can define whatever value we require. Now the footer part, if you see this home, so this is the home button that I was talking, that method of the Wi-Fi navigation, Wi-Fi, so that navigation method that it was calling, it was designing this navigation part like home button. So here if you tap, it will move to the home screen. Similarly for the BLE, same layouts, everything is same. Just one difference in this display in this dashboard is that the footer height I have increased. Earlier there was 9 rows of record, and the footer was little thinner, like the height was less. But to accommodate the button, we reduce this number of records that we are displaying. Now we are not displaying 9 but the 8 results, and the size of this, the footer size, the height I have increased it so that the button is easily visible over here. So again this will tap back, it will come. Similarly for the Wi-Fi, again here same thing, we tap, it will go back and it will display. So the color, everything else, the scan result part or the BLE scan result or the Wi-Fi scan result is same. There is no change in that. So this is how the episode 4 code we have merged with the our new framework on touch. This third button is now not yet implemented. This will come in the future video. The battery is what the screen layout we have designed. So the way it will look like is this. So it will show the current battery status, and again the button, home button, to move back, it will show the battery voltage and the percentage charge left. So this is right now the dummy. So this is how this framework it looks like. Now the few things that you need to notice, you will notice that the color background we have made consistent, so that the black background over here and the black background is integrated. Button size text, we have make sure that since we have defined the coordinate of this home button in at one place, so we are reusing the same place. So whether you are in the BLE screen or whether we are in the battery screen or the Wi-Fi screen, the home button location is same. So there is some issue if you notice that when we are scanning, the button is not displayed. So there is something missing in the code we need to update. This is not there when we are in the Wi-Fi. So over here, when we call first time, here it is showing this button. So some issue in that some one method call is missing. We'll need to fix that. But otherwise it looks okay. The code is working, and this is all about our Wi-Fi scanner with touch integration. Or if you need any further upgrade on this, we'll try to include that. So do update on the comment what additional features you want. One thing, that is the battery part, that is definitely pending. We'll cover the actual display of the battery information. Touch. Also, so now our this project is almost 90% complete. The parts that are still left is the battery screen, though we have designed this, the UI part, but the working is pending. So we'll try in our next episode, we'll try to include this working of this battery, and in the next episode we'll make it a little short and will not increase it. We'll just add this battery. The other screen, we have left it as dummy for future projects. Anything that we want to use, whether if we want to use the SD card or some other functionality, depending on that, we will try to use this. It's just a dummy button right now. I've just added so that the UI looks consistent. Otherwise that is not working. And this battery one will, in our next episode, will cover that. And what we'll do is that in the next episode, we'll finally end this series. Earlier my plan was to end the series in this episode, but since the video is getting longer, so we'll end that at the in the next episode, that is the episode 6. So far, hope you have liked this, and if you are successful, just do let me comment. If you are facing any issue also, then also you can comment. If you are successfully built, then also you comment it out how it goes for you. The next part, that before I wind up my video over here, we'll move to the code also, and to give you a final touch and some explanation over there also. But before moving to that screen and the code, two things that you need to understand. One, I have already mentioned that while powering up with battery, you should not be powering with ESP32 micro USB connector. That is the one thing. And second thing is, while using this pin connections, as we have faced earlier also in my earlier episodes and in this also, so make sure that your jumper wires are tightly connected with the ESP32 or to the touch screen, because sometimes the jumper wires get loose and the results is not correct. Or sometimes the pin connection, while we are connecting it, if the pins are next to each other, like 16, 17 or 25, 26, there is a possibility of the it getting swapped with the other one. Like instead of 25, 26 connecting, you connect 26, 25 to the respective pin of the touch screen. So that precaution you need to take. That is these two things is the important thing, because in this setup right now we have too many connections, like 6 to 7 pin for the display, and then 5 pin for touch, and then additionally we have a charging pins over here, VCC and ground, 2 ground pins. So you need to you need to be careful on that. Otherwise this is all straight simple. And So before closing our episode 5, just to just a recap. So in this episode we use these pins, T underscore DO DIN for 1617, clock and CS 3225 and IRQS 26. And in our for our display that we are using from our previous episodes is the our pins like CS as GPIO 5, reset GPIO 4, DC pin GPIO 02. We were using earlier 02, but we changed to GPIO 27 because 02 was giving issue. So that's the change we did in our previous episode. MOSI and 23 and SCK as 18. MISO is 19. These are the pin connections that we are using, and along with that VCC and ground. So again, for this, as I mentioned earlier, this is important. We are powering VCC like the touch with 5 volt from the ESP32. And again, if you are since we are integrated with the battery, so this VCC is common. When we are powering with the battery, we need to pass the voltage to ESP32 also through this VCC pin, and to this touch display also, in the display also with the 5 volt DC from the battery, and the ground should be common. So that we have already covered in episode 4. So the way we have designed, if you the framework, the navigation framework is covered over here. So from the home screen, which have the 4 buttons, we can move to Wi-Fi, BLE or battery screen. The 4th button is not working, that's a dummy, so that I have not drawn over here. And each, like whether it's Wi-Fi, BLE, it will scan and refresh every 10 seconds. Battery, it's a UI is dummy, it just shows the hardcode value. And from each screen we are having a home button which will take me back to the home screen. So this is the touch navigation, the complete touch navigation that we have designed in this episode. And hope you have liked this video. Any issues, any doubt you have, you can just comment in the video comment section, and we'll try to answer as soon as possible. And thank you again for watching.